So thank you very much for coming here. I am Edouard Aligan, and I will be your host for this presentation today, which is going to be about Multiplatform C++. By Multiplatform C++, I will not talk. I will get into the details of the topic because it's so vast. For example, I'm not going to talk about smartphone development, like doing a program on the iPhone, Android, and Windows Phone, etc. To be about C++, but it's also about multi-platform programming in general. And everything which is in those slides come from what we've experienced when we wrote our software, which is multi-platform. But before going into the details of this presentation, we will start with a very advanced program. Do you think this is a multi-platform program in the sense that given a reasonably recent desktop computer with a reasonably recent compiler, even a 03 C++ compiler, will you run into problems? Do you think there are portability issues or anything that might trigger your mind? By recent, I mean not so long ago. On some platforms you had to write include iostream.h, but let's say you don't have this problem. So any idea? No. Well, I think this, as far as I know, and unless there is maybe an idea. Yes, you're right. But yeah, if you want to be pedantic, you could say, okay, but okay. The question was, do you need to add return, for example, 0 or? To be honest, I think you have to type return exit success. And not 0 or 1. Exit success? Okay. So no, what I was saying is by default it should return success. So you don't have to. In this series of example, I'm going to be a little bit vicious. The problem is not what you think it is. Maybe you're going to get performance issues. On some platform, maybe you're going to have the error output synchronized with the standard output. In this case, okay, I don't think how it could be a problem, but maybe you're going to read the whole content of file and you're going to print it on the terminal. Let's say you just want to write a very simple cat. And you would have to do this on Windows. Because if you don't do this, you will say, oh, I don't understand. On Windows, my cat program is so slow. And you have to add this line. And that's typically the kind of traps that are hard to overlook because it compiles, it runs, it behaves correctly. But then you have feedback from a customer who is using your program in a different way that you are using it. And you realize you have a nasty problem. But I will be even more vicious and saying, we were dining with Eric the other day, says, I'm going to re-implement the whole STL because std getLine doesn't work the way I want. And in this case, as you know, iostream is maybe not the best part of the C++ standard library. And that may be an understatement. And you may want, if you really want to get good speed, you have to write directly to the output with the C function. In that case, you could even say, oh, well, you should use write, because fwrite might buffer a little bit, which is going to impact a little bit performance. This has to be benchmarked. And this is going to be fast on all platforms. Because you're directly going to write, you're directly going to bypass every fancy buffering you can have in iostream, especially because on some platforms, you want to buffer a lot output, and on some other it says, no, I don't. And there is no right and wrong. I mean, every platform has its logic. So you start to do that kind of thing, and remember that this is our hello world, giggity. And you say, okay, so not saying this is a better code, I'm just saying this is going to be more consistent on all platforms. So it's, and there are a couple of slides more. We're going to maybe, I'm using a Boost predef for the macros, and I'm going to, I have a couple of slides about this because it's very useful. I say, oh yes, but I did something wrong here with the buffering. And on Windows, I had a pop-up box, which is annoying. I say, oh, okay, no problem. So on Windows, I'm going to do the specific calls to disable that, and I have the error output the way I want. So already you're adding new lines because you just want some consistent behavior, or you want to use a very specific feature of an operating system. So it starts to get very nasty, but we were in English, and one of the nastiest thing is when you want to use a language where you are not using the ASCII character set. And you have to use one other horrible thing of C++, which is everything which is local settings. And why is it horrible? Is because behind that, you're making calls to the operating system, and every operating system works very differently when it comes down to character sets, localization, etc. And I have a slide about this. I will not talk too much about localization because, first of all, I know nothing about it. And secondly, I don't think it's super interesting. But let's say we are Russian and we don't want to put giggity, but privyet, which means I think. Otherwise, I think I've insulted a large amount of Russians. You have to not only set up your encoding into the local. I think in this case you don't need because you directly write to the console. But you also have to make sure that the encoding of your file is correct, that your compiler is not going to choke on UTF-8 encoded files, and that, well, it's maybe more the work of the user, that the terminal is also properly configured as well, just to write hi. And when you are just, maybe if you're Russian and you're working with Russian people, you are all using the proper encoding, so you don't have the problem. But let's say you have an international team. Let's say you have a team in Europe and one team in China. You say, okay, the program is in English, but at some point you have someone in the team writing comments in Chinese. And so the team in Europe cannot open the files anymore because it's corrupted, because you didn't say you should encode all the files in UTF-8, or maybe you didn't start it from the outset, and you have some nasty problems. So what I mean by that is once you have done all of this, you just need to make sure that everything compiles on all the compilers you are using, which is making sure the flags are right. When you want to optimize your code, that can be very nasty because you want to use maybe some vectorization in some compiler, maybe you want to use special features, etc. And once you have done that, you need to link, you need to test, you need to run, and it very, very, very quickly becomes a lot of work. And if you do your homework right at the beginning, you will avoid a lot of problems. And this talk is about this. It's about how we organize ourselves to make sure that we can support a lot of platforms, and the day we want to add new platforms, it's not going to be too painful. Well, I hope. Let's be a little bit philosophical. It's a large tree. If you get the reference, I'll buy you a drink. What is writing software? So, okay, you know in France we don't like to work, but we like to think. What is writing software? Why am I asking this question? Seriously, if someone came to you and say, what's your work? What's writing software? What does it mean? What are you doing when you write a software, when you write a program?
I tell them I'm a professional symbol permutator and concatenator.
So he says he's a professional symbol permutator and concatenator, right? Yeah, that's right, maybe. In a way, you're just transforming the electric impulses in your brain into other electric impulses into the CPU. But unfortunately, there are many abstraction layers to help you doing that. We've been beyond the punching card programming system, I think. At no moment when you write your program, you say 0, 1, 0, 1, 1, 0, 0, 0, 1, which is in the end what's going to be your program. So you are going through a series of abstraction layers, so you could say programming is just transforming a concept into other concepts. It's a way of formulating it. And why do I talk about this in a multi-platform C++ presentation? What I mean is you're always multi-platform because your program is not going to run on your computer. When you are a junior programmer, I think you already had the bug. Well, we have a bug in your program, and you say, no, it's working on my machine. And it's because on the machine, on the test machine, maybe you have less memory, maybe the user did something you didn't think about. And if we consider our program, and we could also consider some high-level library, below you, you have a tool chain, compiler, linker, interpreter, virtual machine, doesn't matter. And then you have the operating system. And then you have the BIOS. And then, eventually, at some point, you have hardware. All these abstraction layers are leaky because the operating system cannot hide from you that you are out of memory at some point, or that you do not have any space left on your disk. So it's not, when you're doing a multi-platform program, what you want to really understand is that in a way you're just using APIs, that is you're talking to a compiler using a predefined set of instructions, C++ language in our case, and you could say, well, I've said to the compiler, do those things. And the compiler is going to say, okay, so operating system, he wants to open a file, how do I do that? But the tool chain cannot hide from you everything. And this is why you have problem when you do multi-platform programming. Even if you are running on a virtual machine, even when you are working with Java, and you say, well, I don't care, it's running in virtual machine, the virtual machine is going to solve all the problem for me. It's not true, because when you do Java, if you run in a 32-bit or 64-bit Java virtual machine, your program is not going to behave the same way. So this is at the heart of the problem. What's hard with multi-platform programming? And what is a multi-platform C++ program? When do you say, my program is multi-platform? And by that it says, that is not saying, well, it supports multiple platforms. You could say it compiles. For example, you say, well, it compiles in Clang, GCC, so it supports different tool chains. Well, you also want it to link, and you could say it's a joke when I say that, but it's not. Because in our case, we had very specific compilation problems, and we had some very specific linking problems, because the library doesn't exist. Oh, on this platform, maybe we want to do a dynamic library, not a static library. Oh, on this platform, doing static libraries is so much harder. Oh, the DLL, it doesn't work the same way. And it's very time consuming. And you have to rethink the way you organize your program. Well, at some point you want it to run, but you also want it to run consistently, because in the case of your CAD program, you want to offer the same set of features and same set of performance, same level of performance. But even better than that is consistently and using all the gimmicks of the operating system. A very good example is the settings of a program. How do you store the settings of your program? Because if you do that while we write in a file, and I don't care, you see, it's not very good, because on Unix, typically you're going to have a dot directory at the root of the home directory. But on Windows, you're going to maybe use, it's no longer the very good fashion, but the registry. Or maybe you are going to use the user settings directory, but not with the dot prefix directory. And as you can see, this is not something related to the C++ language in itself. You have to detect that you're on a certain platform, we're going to write different code, different logic. And I think a multi-platform C++ program it runs consistently and idiomatically on all platforms you say to support. I was running out of large trees, so well, it's a tree from Bing, because that's what PowerPoint seeks. So just a few words about us. So you have a context. It's not to sell the product. If you're interested in what we do, just go to our website. We are one of those companies doing yet another database, but it runs on Windows, Linux, and FreeBSD. It's very server-oriented, so in this talk you will see that I omit a lot of things which are maybe for desktop applications or embedded applications. Keep that in mind. While I'm not going to pitch the software today, if you're interested, just talk to me. As I said, we really support Windows, Linux, and FreeBSD natively. That is, it installs, it runs, no fine print, and that was painful, really painful. More details, because all the build chains are very, very different. We use a different STL on every platform, a different compiler, and even within a platform, we have platform portability issues. From Windows, when you say, I want to support Windows XP and Windows 8, we will see that you have some pitfalls. And on Windows, we are 32 and 64 bits, which means we have to, in a way, support two CPU architectures, and other platform only 64 bits because it's not relevant 32 bits anymore for servers. And yes, different STL, etc., and compilers. A lot of work, so it means the code is really going to a totally different chain. So what could I say now that we've done it? Would I do it again? Yes, certainly, because the cons are it's much more expensive to write, obviously, because you have to test everything several times. And you get a lot of inertia. That is, when you want to add a feature, you have to really think about the feature. You have to think in terms of how is it going to work on Windows, or is it going to work on Linux? Do we have the necessary features from the operating system everywhere? But in terms of quality, I mean, there is no... the number of race conditions we had on only one platform. So, for example, you get a race condition of FreeBSD, and there is no way you can have it on Linux or Windows. But you know you have a race condition. And this was very, very helpful, and the value of it was very high. Because you know that race conditions or that kind of weird memory problems are very hard to reproduce. And so because you have a totally different timing, because you have totally different chain, some bugs appear on some platforms. Compliance, because you go through different compilers and different libraries, you know that you are writing, I mean, as far as possible, standard C++, so it's going to catch all the mistakes you can do. Satisfaction, I mean customer satisfaction. When we go to a customer, he says, well, we have our servers on Linux, but the clients are on Windows. How do you do? How do you manage that? Say, no problem, Windows is fully supported. Say, oh, great. No MingWi, no compilation, no, just take the DLL, and it's fully tested and fully supported. And flexibility in a way that you are not going to tie yourself to a specific vendor. That if at some point a platform is dying, no problem. And even when a new platform appears, because you have already all the infrastructure to support multiple platforms, it's not going to be that much work. So I'm not going to talk about the macOS specificity because, well, it's server-oriented software, so I have really no experience in it. No GUI. I think it could be a totally, it's a complete different presentation to talk about doing a multi-platform GUI. So no Metro as well, because in Windows 8 they added some very new ways to do applications and to install them. We're not going to talk about that. As I said at the beginning, no telephones and no bicycle shed about, oh, you should use VI, oh, you should use... No, this is really not what you should do, what I'm going to talk about. On the contrary, I'm going to say what you can do to make sure that any of your developer can use whatever tool they want. Why is it hard to do multi-platform programming? Well, programming, generally speaking, is very hard, I think. We tend to forget it because we are standing on the shoulder of giants. We are using very, very powerful tools. Even C++, which is a kind of complex language, it's very magic. You can create programs that take input and output very easily. But multi-platform programming is hard because you are used to develop on your favorite platform, and without knowing it, you may be using buggy abstractions because every platform understands the standard in a certain way. So when you add it, not only the C++ compiler, but then you have POSIX, and then you have the sockets. Sockets is very horrible. I think it's the least compliant thing that exists. Every operating system that exists has some different structure. It's a wrong abstraction. That is, you are using the wrong feature from the operating system, or you didn't understand correctly what your abstraction is doing. And that's why you have very different behavior with your software from one platform to the other. So the toolbox. What we've done, this is trivialities. We've set up at the beginning, we said this is going to be this. I'm not saying you should do this, but in our case we said, okay, we don't want any stupid debate. So as I said, all the files are going to be UTF-8 encoded. We're going to use the Unix line ending. Why? Because Windows supports very well Unix line ending, but not the other way around. Space only, this is, again, because everyone is using a different editor. So with space only, you have some consistent behavior. You don't have some buggy files from one editor to the other. And the file names, which might sound, why do you care about file names? But on Windows, it's very easy to create file names that are cumbersome to use on Unix. So you want to just be very strict with it. And the advantage is that you can very easily write Python scripts to check at commit time that it's okay. And it's going to save a lot of problem. It's, you have, the question is, yes, it's, the question was, what is the BOM less? It means when you encode a file in UTF-8, you have the way to say, hey, this is the byte order of my file. And this is, we chose without BOM because some editors will display the BOM characters and say, oh, and then you have something confusing. You could argue it would be better with the BOM. I mean, it's just a convention you just define. There is really, you could say, no, we use tabs, no, we use the Windows line ending. Just do it the way you want, but it's useful to set that at the beginning. How to compile? So you can create your makefile solutions, whatever, on every platform, or you can use CMake. I think CMake saved us countless hours of engineering, and it's a very, very powerful tool. CMake will generate a makefile for you. That is, you write your makefile once, and then it generates makefile. And I will give you an example. Joël Falcou, no, Joël de Guzman, but we have several Joëls in the Boost community. We were using CMake, and on Windows, so we build with Visual Studio. Yes, because it can generate Visual Studio solutions, which is very, very convenient. And on Unix and the Unixes we support FreeBSD and Linux, we were using Make. And Joël told me you should use Ninja. And the cost of switching to Ninja was just saying to CMake, stop generating Makefiles, start generating Ninja files, and end of the story. So this is the first thing you want to do. No automake or autoconf tools, it doesn't work on Windows. And maybe even if you think supporting Windows is like working with Saturn, you don't know what the future is made of. And I really, personally, I will recommend CMake over the autoconf and automake tools. The process we have, so the meta makefile is CMake, generates your makefile project, then you compile, then you link, then you test. When you have multi-platform, continuous integration is a must, because at every commit you want to compile on all your platform and test and make sure everything is okay, because otherwise it's, oh, 1 month ago we committed something that broke the FreeBSD build. Oops. And the question is, but isn't C++ multi-platform, so isn't this talk a little bit useless in the sense that if I write a C++ standard program, it's going to be multi-platform. As we saw at the beginning, we wrote a perfectly standard program, but we had some issues. So yes, it's multi-platform, and it has come a long way since I've started writing C++. Because now most of the compilers are compliant, and okay, you have some compilers that do not support C++11 well, etc. But you have consistent STL support. Yes, I think Christophe was saying, I think Visual Studio doesn't support C++11 well. Yes, he says, you mean several compilers, but you mean one compiler, yes. But also, maybe you're stuck with the GCC version that you cannot upgrade, and you cannot support the features you want. So, yes, C++ is multi-platform, but you have to really understand the libraries you use. For example, I think thread, atomic, chronomutex, system error, they're very, very useful. I mean, now creating a thread, it's reliable. You call the thread API from C++ and you get a thread. The cost is, in my opinion, negligible. And you saw this 10 years ago. If you wanted to do a multi-threaded program on several platforms, it was very painful. You had to write, use the create thread API of Windows. You had to write use the thread API on the Unix when you had one. Now it's very easy. Atomic is also useful because you have consistent atomics. You're not going to use compiler-specific intersecs. Mutex as well. So it's a little bit system-related because the software we've worked on is a server, so we use a lot of this. I like very much system error, which is not so well known. It's a very, very nice way for a function to return an error, because it's going to be to encapsulate the error message and the code, and in a way which is going to be cross-platform. IOStream, FStream, local, yeah, you can use them, but be careful. First of all, personally, I don't like the way FStream works. I find it to be a little bit cumbersome, but it's a matter of taste. And IOStream, as you've seen, you have performance issue that you may have also with FStream, and local also doesn't do what you think it does. And there's also this facet memory leak issue, if ever you've tried to use facets, but I don't think it's local. I don't remember which header it is. But don't forget that you can simply use C functions. As long as you keep portability in mind, it's very safe. Personally, we use those functions at some point to open files. The problem is, on every platform, you're going to have to be a little bit careful with the option names. Also on Windows, there is the notion that a text file is not a binary file. Memcopy, etc., and blah, whatever, because I'm not going to list every C function, but don't forget about this. This is very helpful. And the thing is, as I said, you can use open, but yep, doesn't work. Absolutely, it's absolutely totally different on Windows and Linux on FreeBSD. So you want to maybe, in that case, seek to the end of a file. On Windows, as you can see, I don't know why, you have an underscore in front of the function. You have to specify that you want the 64-bit version of the API. And you also have to specify that you want to open the file in a binary mode, or maybe not. And that kind of thing is the traps you can have. But if you can encapsulate that into function you write, this can be very simple. That kind of line is your code should be filled with this, because the way in that case I'm not know what the standards say, but using the explicit integers with explicit size is a must in multi-platform programming, because if you start to assume, yes, my int is going to be 4 byte large, this can lead to very, very nasty errors. So that kind of static asset is very useful because the way you compile a new platform and it doesn't work anymore, it's going to break at compile time and not at runtime. Boost libraries, obviously. File system is one I like very much. Predef, we're going to see about it. It's a library to have that gives you a set of predefined macros, very useful. Program options, program tree, property trees, date time, many other, I'm sure. Azure, even if you don't do asynchronous network programming, Azure gives you a socket abstraction library, which is very useful because every system has its own socket specificities. Now, with third-party libraries when doing multi-platform, if you consider the number of problems you have, it's a factor of the number of libraries you have, the number of toolchain and architectures. So every time you add a third-party library, you are going to add a lot of problems. In our case, we are very conservative when we want to add a new library into our build or in our software, because it easily creates a lot of problems with compiling. Is it supported on every platform we support, etc. So this is back to the inertia I talked about in the beginning of the presentation. Not saying you should not use third-party libraries, but just be conservative enough to not shoot yourself in the foot. And as well, so now we start to have on all compilers a very decent C++11 support. But remember that you're going to be dumbed down by the lowest common denominator. In this case, it's Visual Studio. Yes, Christoph is again making a snarky comment about Visual Studio. Yes?
We cross-compile to a bunch of different Linux distributions, and the default GCC on Red Hat Enterprise Linux and SUSE Linux Enterprise Server is GCC 4.1. So
yes.
That's actually our lowest common denominator.
So the comment was we cross-compile on many Linuxes, and so on Red Hat Enterprise it's 4.42. 4.1.
6 years old.
GCC 4.1, which is 6 years old. Yeah. So.
So it's not always Visual Studio.
Yes. Yes, that's true. It's not always Visual Studio. In our case, we distribute. We give a binary. So we don't have this problem, but yes, when you distribute your software in a source code mode, you have to think about it. And thanks to Boost Predef, it's very easy to do some checks at compile time. I will show you how to do it. So the the naive approach when you do multi-platform is, oh, well, in 2014, I should not have any macros specifying which platform I'm using because C++ is multi-platform and everything is easy. You will not be able to avoid the fact the code samples I show you where you have a if Windows, if Linux, if FreeBSD, if whatever. Just be clever to regroup that into, for example, what we have in our case is we have a system and OS tools libraries. Try to package every very specific stuff. And even that you will have at some point, maybe because a compiler is not correctly supporting a feature, but you want to have it anyway. And maybe another example is you cannot abstract away a parameter to a socket, and you have to have a little bit of platform-specific code. Have an example with that. So with Boost Predef, it's pretty easy. When it came out, I think it's in Boost 154. We switched to it immediately because it's simple and it externalized the problem, which can be very, very painful. So, straightforward example: you have a function, and you are out of luck. On every platform, it's going to be totally different. So, with Boost Predef, it's just a matter of say if Boost OS Windows, blah 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 Windows. If Boost OS FreeBSD free, blah 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 FreeBSD. And by the way, it detects OpenBSD, NetBSD, etc. If Linux, something Linux. So this is the basics. But if you do, for example, want to check that you have the proper GCC version, say, well, I will not compile if I do not have GCC 4.0.0. You can do that very easily that way. If you have working on the Itanium platform, which it's strange, but who knows. This way it's very easy, and it really is comprehensive in terms of platform. And if you want to write your own macros, you're going to spend a lot of time on research. But now it's free of use, it's add-only. Really, you should not hesitate to use it. Yes?
So CMake also has abilities to, do all these kinds of checks and find out things.
Yes.
Tell you. And their best practice recommended is instead of testing for specific architectures and compilers, to have a feature-based macro. Do I have a particular feature, and then I can use that. Did you have that?
Yes, we have both.
Why did you prefer pre-dev?
Okay, so the remark was CMake already allows you to do some platform-specific code. And so we could, from CMake, detect that we are compiling for AMD 64 or for Itanium or for whatever. And why do we have this? We do some triage in CMake, but sometimes it's just 2 lines of code. So you're not going to move the code to a specific compile file, because in CMake it only works with files. We could, what we do is you have to do some triage at the end because it's more convenient, it's more flexible, and we have some selection. For example, we will compile certain files if we are on Windows or if we are on Linux. But sometimes it's just a small amount of code, and it's also convenient when you work on your file to have all the versions in the same file, because it's a very small amount of code, and you want to make sure, I'm going to do a modification on FreeBSD because I'm using a sys parameter. And if you have everything in separate files, you might miss that. So it's really a question of the amount of code and complexity and what you want to do, but we do both. I hope I answered your question. So obvious issues, I will go very fast on these issues because if you are a little bit experienced with C++, this is everything you could imagine very easily, the kind of issues you can have. Compilation, obviously, compilation, different compilers, errors, options, macros. CMake helps you with that. We have a pretty large file which is just about setting the compiler flags right. But once it's done, it's done. That's why CMake is really good. It's okay, it can be very painful to write, but it's written once. And you don't have to change. And if you have to do a modification, it's in only one place. Some obvious differences between Windows and Unix, because within Unix you have differences. But you have some very, very big differences between Windows and Unix. For example, Windows is UTF-16 by default. No, it's not by default. Internally, the kernel is UTF-16. On Linux, on Unix, on whatever, depends. It's even configurable, I think. Windows, you have derived liter and UNC path, the // blah, blah, blah. On Unix, you have mount points. On Windows, it's you have a GUI on Unix, obviously, but Windows is built around a GUI. That is, everything you do in Windows, you have a GUI. It's always there. On Unix, it's terminal-oriented on many applications. But you have a GUI as well, but it can be different. It can be KDE, it can be GNOME, you don't know. On Windows, that one can be very nasty, it's going to use the library you have in the directory of the application first. Well, not exactly. We will see the full path deduction. On Unix, generally, unless you override it, it's going to use only the system libraries. And Windows likes to lock files for no reasons. And that can lead to very, very nasty bugs where, because, for example, in Google Level DB that we use, and we have our own branch that we maintain, there were a lot of tests that didn't pass on Windows because the test assumed that they could open the files again. And on Windows, it was not the case because the file was locked. In Unix, it's pretty rare you lock a file, or you have to do it explicitly, but I cannot think of all the cases. But okay, so that's some major differences, but this one is very nasty. If you compile today, if you create a program on Windows, I think by default it's going to be UTF-16. And it's you have to know that actually, for performance reason, it's better to use your program to write your program in UTF-16, because internally the kernel is UTF-16. So every time you're passing a non-UTF-16 string, there is some conversion going on. In some cases, it's very fast and you don't care. Some of the cases, maybe not. So some path examples. So Windows, Unix. You have to know that Windows fully support the / for a directory. So you don't have to take care about this. But this doesn't exist on Unix. When you eat up a path, fortunately you have the boost file system which supports path parsing, which is very useful. But depending on your application and what you're doing, you might not expect that kind of thing. You can, for example, maybe you do some sanitization of your inputs, and you're going to say on Unix, well, you will only accept that kind of characters, without accounting that you can have this on Windows, or that you might have a drive letter. So the library search order, it's very important to know it, because if you distribute your application in a binary form like we do, you want it to run correctly and use the correct libraries. On Windows, the library search is a little bit elaborate. It's going to check if it's already loaded, if it's a known DLL in a list to prevent the DLL hell. Then it's going to check in the application directory if the DLL is there. If not, it goes in the system library, system directory, which is very important. It means that if you have the two DLLs on your operating system, on the application directory and in the OS, it's going to use the DLL you have in your application. That may or may not be what you want. On Unix, it's totally different. It's authorized directories, and then it's going to use the rpath of the binary, which may allow to load the library from a different path. That's what we do to make sure that it loads our version of the library, especially because we give also the right GCC system libraries to make sure that either it's not present on the operating system or it's a different version, and that's going to cause problems. And then it's going to use the library path environment variable. It's not super sexy, it's not super interesting, but this is the kind of detail that, oh, I don't understand, this Windows version, it doesn't work. Yes, because it cannot find your DLL, so you have to make sure that you have all the proper DLL, or you are assuming that it's going to use a different DLL, or in Unix it's not using the libraries, or you forgot to supply the library with it, and that kind of stuff. And the credentials are also an obvious issue, because you have a different API on Windows and Unixes. How do you set up file permission on Unix and Windows is so different that if it's important for your application, you have to keep that in mind. Sessions, which is Windows-only thing. For example, a service is running in a dedicated session. The login, the tokens, the terminals, all that kind of things. They are very different, and maybe your application doesn't care about it, but just make sure that, okay, did we think about everything? When we create a file, is the mask important in Unix? How is it going to behave on Windows? So it's just a question of logic, and because it's pretty obvious, generally you get that right very quickly. Because in the first test, very quickly you're going to see, oh, you're doing something wrong. But the pitfall here is when it's related to security. Because of file permissions and login and tokens and privileges, you have to be very, very careful to make sure that you are secure on all platforms. Another example is daemons. Yes?
It's also a very big difference in the security model between those two platforms, that Unix is separate access controllers.
Yes, yes. The comment was in Unix you have user group and others, and in Windows it's very what they call the ACL, which is the access control list, and you can do very, very complex permissions, and sometimes you can bite yourself very hard and deny yourself all the permission on the files, etc. Which one is the best, I have no idea.
It's coarse versus fine grained.
Yes, exactly. It's one is very fine grained and the other is very broad. It's very straightforward. So sometimes you miss the ability to give rights to specific users on Unix, but on Windows it's sometimes very easy to forget that you gave permissions to something. And in the also the API on Windows can be very painful to use because you have to get the tokens, you have to get, because you identify a user by grid, and you have to get the grid from the username, and yeah, okay. And when you are within an Active Directory system, this is another story as well. So daemons, it doesn't exist on Windows, it's called a service. You have now this call that I really encourage you to use on Unix, which makes everything right when you want to do a daemon. Privileges, no, I don't think it does anything related to privileges, I'm not sure. But it creates a daemon correctly. On Windows you have an API which is not very difficult to use, but it's different. And again, if you want to use the gimmicks of the system, on Windows, if you write a daemon, you don't want to have a terminal window and something that runs in the background, because you want your daemon to run when no one is logged. So to do that, you have to write a service and use the service API. Configuration, I've raised that issue at the beginning of the talk. The configuration files nightmare. I'm talking about reading the configuration from a system. That's very nasty on Linux, because every Linux distribution is doing, yeah, we are kind of the other, but hey, in your case, if you want to know the version of the operating system, you have to read that file. So on FreeBSD, you use a CTL to get information. On Unix, you have proc, and you have the Windows registry on Windows, and you also have the WMI API, which is very powerful to use, and you can query really anything. But again, this is a case where you're going to write a lot of different code, but it's obvious. I mean, because it's just not going to work when you work to program if you do not use the right API. It's going to be a lot of work, but it's not nasty in the sense that it's going to be obvious. So multi-threading. Multi-threading is, generally speaking, hard. And if you want to support multiple platforms, I would strongly suggest not using this. First of all, because I think StudAsync is the wrong API for the program. I think it's a useless API, to be honest. Future, because of the performance discrepancy you can have from one platform to the other, you should be careful with it. But thread, mutex, condition variable, it's very safe to use. I've used them for years, no problem, and no performance difference. And you should really use that because it's going to make your life very simple. Serialization, this is a nasty problem. Indianness, today, I think the ARM platform can be a problem. But in our case, we assume Little Endian byte order. Although we have something that checks everything is serialized in the right order. You have some nasty things like floats and alignment and sizes, which is not directly related to serialization, but if you do some fancy things related to memory within your program, you will be very surprised between the differences between compilers and platforms about alignments and sizes of your structures. So be very, very extra careful with this. Do not assume anything, especially when you're going to disk. And it's an obvious issue because testing it is just serializing in one platform and deserializing in another platform, and you see very quickly if you have something wrong. It's broken? Yes. Okay. No. 32-bit, this is 64 bits. Again, today, if you are 64-bit only, it's no longer a problem, but in our case we have Windows which is both 32-bit and 64-bit. You have to be careful with sizes, that's a classic one. APIs may change, especially in Windows. And the memory allocation, the thing is, you can make very large allocations when you're in 64 bits, and it can crash your system very easily, so you may want to do some sanitization regarding the inputs. And also you can have performance differences between 32-bit and 64 bits because you're going to get maybe memory fragmentation on one platform and not on the other. But again, that one is obvious because you've been told so many times that you can have traps that you're going to be careful, right? So networking, yes, just don't try to say, oh, we're going to write our own socket abstraction library. Well, if you already have it, done it well. But really, just don't do it. It's very, very hard, and I've done a lot of kernel system programming, so I have a very high threshold regarding pain. It's nasty, it's not interesting, it's a waste of time, and it's a waste of money. Just don't do it. Use Boostasio. Yeah, so you might want to use some fancy features of your operating system. In that case, on Windows, when you accept on a socket, you want to be a little bit secure because you want to protect on some attacks. And Windows has a feature where you can say, we want exclusive address use on the socket when we accept. It's an example. So let's say you have, this is a good example, for example, of why we don't triage everything in CMake, is because we just have this very small amount of code that we want to be accessible at any time. On Unix we do that, just, okay, we use address. On Windows we use a more fancy option. So on Azure you can access the native socket, so don't be afraid to use Azure because you can, if for some reason you need to do some raw socket stuff, you can do it. Okay, so now we're going to talk about the more subtle issues you can have when doing multi-platform, which I hope is going to be more interesting. Debugging, just debug on Windows. That's what I want to say. No, because you have all of those fancy macros definition that varies from one platform to the other. You might want to use on Windows those features. If you won't use the standard libc++, you want maybe to use that. And you want to make sure that all the debug are properly defined on all the libraries you use, because maybe you are using a third-party library that's going to check _debug, and another one which is going to use the debug one. And when I say try to debug on Windows, it's a little bit of a joke, but personally, when we have a bug on Linux, whatever it is, or FreeBSD, the first thing I try to do is to reproduce it on Windows to take advantage of the Visual Studio debugger. But that's just me. Okay, localization, it's horrible. You have to think about so many things, and it's not related to C++. You will have to understand on every platform how localization works. If you, I don't know, if you're writing an application in Hebrew, you have to care about the reading direction. How do I set up the reading direction on this platform and the other? The language, the time zone currencies. Time zone, it's a little bit, you have to be careful because very easily you want to get the time, and maybe are you getting the UTC time, the GMT time, the local time? So that's the kind of thing you have to be very careful with. I'm going to, I was hoping to say I wrote a blog post about this, but I'm going to say I will write a blog post about this. You want to create a high resolution timestamp. In our case, we want to do that because we use high resolution timestamp for many things inside the software. On Unix, it's get time of the day, and some fancy arithmetic depending on if you want milliseconds, nanoseconds, microseconds, seconds, whatever. On Windows, you have to do the query performance frequencies, that is how many times per second is going to be updated the high resolution timestamp. Then you do a query performance counter to get the counter. Then you do some arithmetics. And then you do a query performance counter again. And then you do some arithmetics, and you have the same result that in Unix. In that case, it's harder on Windows than in Unix. But sometimes you have a more convenient API in Windows than on Unix. And it's a typical example of if you are not very careful, you say, OK, so on Unix, it's easy, get time of day. I'm going to just do a get time of day on Windows. And if you are not very careful, and if you do not read the documentation carefully, you will not be aware that on Windows you have an accuracy problem. Yes? Yes. The question is, doesn't Windows have get system time as file time? But it's not as accurate as you want. As we wanted. It's more accurate. No. Yes?
If that one is not good accuracy at all, then they come out with the precise, and that does have.
Yes, you have, the comment was that you have get system file time as, get file time as file system time precise. And I think it's not accurate enough. Because this one, it's going to be, I think, microsecond precise. It's very, very precise. Actually, what it does, it's updated every time. At every instruction, you're going to get a different value. Because in our case, we wanted something monotonic and very, very accurate. Like with your case, it's not updated enough that if you do 2 successive calls, you're going to get the same value. And you're going to be, also if ever the user changes the time, you're going to have a problem because you're not going to be monotonic anymore. That is, you're not going to have a value that is always greater than the previous value. But in many cases, you're right, it's enough. In our case, we really, really needed something very precise because all the transactions depend on data. Error management. So it's a case where Windows is much better than Unix. On Windows, you have something called the structured exception error or exception error handling error exception. And on Unix, you have signals. On Unix, using signals like to capture properly the segmentation fault signal in a safe and portable way, it's a lot of work and it's a lot of debugging. On Windows, just follow the example. You have an API, it's really safe. You can really do memory access violation, transform that into a C++ exception, and safely continue. To have this on Unix, you need support from the compiler, which you have in GCC but not in Clang. And you need to do some fancy, I have in my signal, and I have to use, the only synchronization primitive I have is, if I remember correctly, it's semaphore. Yes?
Sorry, SEH, you said you were translating SEH,
C++ exception.
access violations.
Yes?
That is not safe.
It's safe if...
Do not guarantee that you're safe.
there is a safe way to do it. I can show it.
That'd be very interesting.
Yeah, there's a safe way to do it. It's just you have to know that you have to capture, every time you create a new thread, you have to call the right API. Or maybe we have a big bug in your software.
I believe so. That's pretty much it on every thread, but moreover, many threads are not forward. But moreover, I think you can still leave even in undefined state.
Yes.
Even if you've done a manipulation.
Okay, I see. So the remark was, if you do SEH and you do a memory access violation, you might be in an undefined state. Okay, what the doc means is, of course, if you are totally corrupting your memory, you will not be able to get back on your feet. But if you do something just like accessing a null pointer, this is safe. Yes, definitely. Differences within the same OS. Because you were happy and you have your program running on Windows and Linux and etc. But you have to support different versions of Windows. FreeBSD versions are incompatible, a major version are incompatible between them. Very often you just have to recompile. Linuxes, you have so many distributions. Unix's differences, so this one is not that known. You say, okay, if you have on FreeBSD, you have different functions that are not available. That's just two examples. Different libraries, EPOL versus KQ on FreeBSD. Maybe you don't have the same STL, so that kind of thing you need to know. On Windows, you have to be very explicit about what you support, because you do include Windows Edge, and maybe you want to use a new version, but then it's not going to run on Windows XP. So this is what you do if you want to run on Windows XP Service Pack 3. But maybe today it's reasonable to say I want Vista or 7 or later. You also have on Windows XP if you want to support a new, like in this sample, compiling Visual Studio 2013, you have to tell, oh, by the way, use the shell library which is compatible with Windows XP. If you don't do that, your program is not going to run. Yes? Yes. Yes. And most of our customers are banks. The question is, it really depends on the geographic situation, where you sell your software. When you sell software, the remark was, for example, in China you have many Windows XP, and so maybe you really want to support Windows XP. And in our case, we are working with banks, and they are very slow to upgrade, and they still have many Windows XP. And I think in 2013, in 2050 and whatever, there's still going to be Windows XP. And we have to support it. It's not a question of, oh, it's stupid, etc. Yeah, but that's what the customer is using. Also in CMake you have a switch to be explicit. So it's only a very recent version of CMake, so another reason why CMake rocks. So now the interesting part. Memory allocation. Oh, but I just do new, or at some point allocate memory, and I should not care about what's going on. Except that every operating system is totally different about memory allocation. On FreeBSD you have and Linux you have by default a very decent memory allocator. On Windows you have to be explicit for retrocompatibility reasons that you want to use the low fragmentation heap, for example. Maybe the allocator you're using on Windows is not scalable, which is, no, it's not. Maybe you run into issues, maybe you want to use a custom allocator, and this is very nasty because it's hidden. It's going to work very nice. You're going to run your software, you're going to see no problem. You run it in Valgrind, you run it into, I don't know, Intel Inspector, it works. But you have performance issues, you have different behaviors in some cases, and you don't know why. Very often it's because of memory allocation. And from a C++ point of view, you're doing nothing wrong. You're just doing new, you're just creating an object, you're creating a string, a vector. And so, fortunately, in C++, you can specify allocator, and that's what we do. We have custom allocators everywhere. Yes?
So, Google, I believe, made available a memory allocation library that, was better in many circumstances than the one that comes up. Is that an option that you looked at, or?
So the question is, Google released a memory allocator which is performant in many cases and performs better than the other allocators. We didn't look at it. We used either we have a very tight memory management where we recycle ourselves the pointers, or we use the TBB Inter-Threading Building Blocks allocator. Why? Because it's already we already use it, so, and it supports all the platform we use, and it reduces the pain because in that case it means adding a new third-party libraries for memory allocation, and so that might be a problem. and memory allocation is so difficult, so I'm not sure if it supports Windows correctly. But in the end, don't get your hopes too high. If the memory allocator gives you a lot of speed gain, it's because you're doing something wrong in the first place. If you use memory correctly, and if you are a little bit clever about how you use your objects, the gain from the memory allocator, putting aside everything thread related, where you want to align properly, where you want to make sure that an allocation in a thread is not going to be a penalty in another one, it should not matter that much. But I'm sure it's very good. File system, that was very nasty. Performance, fragmentation, cluster size, it's obvious in the way that you know that you're going to get a different file system on every platform. Even on Unix, you don't know which file system you're going to get. But yeah, sometimes you're going to get a call from a customer say, oh, well, it's very slow, or oh, I get so many files, doesn't work. Be very careful about, for example, creating many little files. It works in your case, but maybe on NTFS it's not going to be very good. Or another example, NTFS is a very resilient file system, and maybe you're doing something a little bit pushy with when you close your file, and you're assuming that you're safe with your asynchronous write, but another file system doesn't have the same cache. So this is very nasty, and I have no solution to offer, of course. Asynchronous I/O. So yes, again, at some point you want to do asynchronous I/O. Boost IGO, which is not perfect. I mean, it has some defects. For example, I think there could be improvements regarding performance when you pass messages. But if you use it as an I/O framework only, it's very well done. You get very good performance. But as far as I know, using it for files, I think it should be possible in theory, but there is a NAFIO library being submitted, I think. There's even a talk about it. Anyway, this is going to be so very specific for every platform you're going to use. So this is nasty because it's hard to get right. And you have to spend a lot of time reading the documentation of every API, and do not assume anything like, oh, this should work like in FreeBSD. No, it's not always. And then this photo was taken by Christophe and I when we were driving between Denver and Aspen. Yes?
So, just a question
Yes.
real quick on that previous slide. You're talking asynchronous file I/O.
Yes.
Okay. Not asynchronous network I/O.
Also, I mean, any asynchronous I/O.
Okay.
Completion ports can be used on Windows for files as well. The question was, you're talking about file I/O only and not network I/O. And so I'm talking about asynchronous I/O generally speaking, because when you care about performance, very quickly you realize that waiting for I/O to complete is not very efficient. Well, doing nothing while the I/O is being processed. Yeah, we'll have to check, however, because yes, I'm not sure if you can. Okay, maybe I will check and answer more precisely this question. So yeah, that's what I hate is, oh yes, everything is fine, and well, on Windows you have half the performance you have on Linux, and you cannot go to a customer and say, yeah, well, Windows sucks. Why you have this can be a very, very long and painful journey. It's not always Windows, by the way. Sometimes you get your software running perfectly, and on some platform you have some unexpected performance problem. And this is very, very, I think it's the hardest point with multi-platform programming, is that for no reason you have a huge hit because maybe you have a bug in the operating system. Maybe you have, you didn't understand correctly how the API works. On Windows, for example, the asynchronous I/O, if you do very large I/Os, you're going to get very strange performance, and it's more efficient to cut that into smaller buffers. And how do you know that without getting without hitting the whole wall first, you don't. I don't have a very good example, so maybe I should have worked my slide earlier than when in the plane. If I can find a very specific example. Yeah, for example, in FreeBSD, the allocator is often a little bit better than on Linux. On some corner cases, you don't understand why, but you get a deep performance difference. And generally, it's a hint about you doing something wrong, but sometimes it's not. Sometimes you have to work around a deficiency in the system or the hardware, or I don't know. And then multi-threading. The hard part is it doesn't work absolutely not the same way. Windows, for example, well, no, I think Windows is 1.1. That is when you create a thread. The kernel is multi-threaded since Windows NT 1.0, I think. On Linux, on Unix, it's going to depend on how the threads are implemented, depending on if you are running on a recent version of the Linux kernel or an older version. So that means you're going to get different timing, again, different performance, different behavior. You run into race conditions on some systems, that means you have a bug, right? But it can be very hard to reproduce and to understand, but because you don't understand what's going on. The timing is different, the model is different, the priorities are different. So it can be very nasty, and it's a little bit linked to the previous slide. And then you have, when it goes wrong, that how does your platform behave when it runs out of memory? What happens when it shuts down? It shuts down. What happens when the disk is full? We had that in production, by the way. And on every system, it's totally different. Some systems, for example, if you have an application that takes too much memory, it's going to be killed. Some other systems are going to panic. Linux, for example, it's pretty easy to panic a Linux machine by taking too much memory, depending on how the administrator configured it. And so when you have your application causing a machine to reboot, it's not good. And you try to reproduce that at home, and you don't understand that it's a problem of configuration in the machine. Or you try desperately to reproduce the bug on a different system, and you don't understand what happens. So another reason why you get inertia and why costs are much higher when you do multi-platform programming is because very often you have to be able to maybe have exactly the same operating system as your customer to reproduce the problem. And sometimes it can be very painful. And again, memory management, it's a very complex issue. Some tools, okay, CMake, BuildBot, that's what we use for continuous integration. Again, you should really have multi-platform programming put aside continuous integration in your application. We also have performance test at every build, because it's the only way to know that, oh, I've done a modification, and immediately I know to a certain extent that I have a performance regression on one platform. Because if you realize that 1 month later, then you go back to this slide. And just to agree on something, you are here. This is what is going to happen to you, and it can be very, very, very frustrating. That actually we initially did not have the automatic benchmarking, and we added that later when we spent, I don't know how much time on performance regression, and it took us, we had to go back in the Git log and test every build and build and build until we realized, oh, this is the performance regression. Okay, some tools, Valgrind. This one is free, and it's going to test that you are not doing something, that you are compliant with what Microsoft says, which is pretty useful. We use that because it comes with some very nice multi-threading tools and containers, and it's supported on many, many platforms. And that's it. If you have any question, feel free to ask. No question? Question?
What have been your
Okay, the question is, what is our experience with the STL compatibility amongst the different platforms? So since Visual Studio 2012, you have full STL support for C++11. The lib C++ is of very high quality, and stdlib C++, even in the version of GCC we use, which is now a little bit old, which is the 4.6, it's pretty decent, but we don't use everything. So my opinion is maybe not very useful. It's gone along.
With STD++, so the standard library still uses copy and write strings.
Okay.
They still didn't rewrite them.
So the remark was in stdlib C++, they still use copy and write strings, and which is now considered not very efficient.
It's not compliant with C++11.
And it's not even compliant with C++11. So do we use strings? Oh yes, I think at some point we do. But other than that, we didn't run into any trouble. We never had a problem which was related to, this doesn't work correctly. But we do a lot of low-level stuff with buffers and memory management. We don't use IOStream, we don't use FStream. So that may explain why we didn't have any problem. Any other question?
Did I hear you correctly saying that you build your GCC toolchain that you use for your distributions?
The question is, do we build the GCC toolchain for the distribution we use? For the Linux platform we target. What we do is we distribute the STD, the standard library, C++ dynamic library with the software to make sure that the client has the right version. But it's unmodified. What may happen is we make sure it loads this version and not the version on the system.
You do that via the R path?
Yes, we do that via the R path, which took a while to make it work with CMake, because there is some nasty character escaping. CMake escapes, then the linker escapes, so you have to put how many backslash there are into our R path, I don't know, but many of them. And we make sure that we use the right library, but it's just in case. Very often on the production servers, you have no compiler or anything. There is no standard library or very, very old one.
Right. Well, that's why we're stuck with 4.1, so that's why I think now I might be able to liberate ourselves.
So the remark that was they had the same problem, that they are stuck with the GCC, but what you can do to avoid that is, and it's compliant with the license, because you just compile, you do nothing with it, just give away the compiled version. As far as I know, but I'm not a lawyer, so do not seek lawyer advice if needed. Yeah, that's what we do, and it works. That's actually, in Windows, that's interesting that we compile with Visual Studio 2012 for now, and our customers links to our library, and they use Visual Studio 2010. But on Windows it works, because all our API are C, so we are sure that we do not share anything, and this is also good advice, because you want to make sure that if you have, first of all, there is no such thing as compatible C++ ABI, and by using C interfaces, you make sure that in our realm we use the Visual Studio 2012 library, and the client uses the Visual Studio 2010, and at no moment do they clashes. And also, our library uses boost a lot, and we have to make sure that we hide all the boost symbols to make sure that the client is not going to accidentally link with our boost symbols. Because on Linux, for example, on Windows, on Unix in general, the binary distribution is a little bit hairy, because you have the linking philosophy is very different. No other question? Are you ready for the picnic? Thank you very much.